10% dissociation of 0.1 molar HClO. First thing to ask myself, is HClO acid or base, strong or weak? Starts with an H, so it's probably an acid. It's not one I memorized. The one you memorize is HClO4, that's different. Not what I memorized, so it's weak. We are dealing with a weak acid. If it were a strong acid, percent dissociation would be 100%. There'd be no work to show. It's just part of the definition. But it's a weak acid, so I'm going to dissociate it, meaning equilibrium arrows, a singular H falls off, everything else stays together. I can do my ice chart. They gave me the molarity of HClO 0.1. I can assume zeros to start there because I wasn't given any values. The side with 0 is plus X. The side without 0 is minus X. And then because weak acids dissociate so little, they barely dissociate, we say that when we subtract X from 0.1, it's still essentially 0.1. It's going to be close enough to 0.1 that we round up to it anyways, so don't deal with the minus X. Since it's at equilibrium, when we have an ice chart, we can use an equilibrium expression. We just now call it Ka. Products over reactants, so H plus ClO minus over HClO. H and ClO are both X's, so plugging in X for each is where my X squared comes from. HClO, we said, was 0.1, and we're using these equilibrium values here. The Ka we can get off of the chart, the Ka value for whatever I dissociated. Of HClO, I see 2.8 times 10 to the negative 8. Then I can keep solving for X, so I'm going to take 2.8 times 10 to the negative 8, multiply by 0.1. That'll get me an X squared of 2.8 times 10 to the negative 9. Square root, and I get an X value of 5.29 times 10 to the negative 5. Why I care about X? X represents my H plus. So if I wanted to find the pH, I would negative log that. X also represents the portion of the HClO that actually dissociated. It's going to be a very small portion. It is 0.00005. But X is the portion of the 0.1 that went away. So percent dissociation is saying, of this original 0.1 HClO, how much of that negative went away? Well, the X value is what went away, so I'm going to put that on top. The part that went away out of the whole is the percentage that dissociated. I just multiply it by 100 to get it into a percent. And I get 0.0529%. Because I multiplied by 100, I didn't have to move the decimal or anything. It's already done for me.